This video we are going to go over Section 1, Part C in Chapter 6, Factoring by Grouping. In this lesson we are going to talk about how to factor out a common binomial factor, and then finally we're going to use that to what we call do factoring by grouping. So suppose you have this expression. It is 3x squared times the quantity 5x squared plus 1 minus 2 times the quantity 5x plus 1. What you'll notice is that each term has a common factor, and that factor happens to be 5x plus 1. And as a consequence, we can use the distributive property in reverse to take that 5x plus 1 outside, leaving us with 3x squared minus 2. It's almost like we could rewrite 5x plus 1 with a capital A. And if we did, we would have 3x squared times this capital A minus 2 times this capital A. And then we could use the distributive property in reverse, and then we would have 3x squared minus 2 all multiplied by this capital A. And then we can replace the A with 5x plus 1. Which brings us back to this result. And that's pretty much that is what factoring by grouping is all about. So let's look at some examples, and we will have two examples in this particular problem. Okay, so the first one is 7a times the quantity 2x minus 3 plus the quantity 2x minus 3. And notice that this binomial and this binomial are the same. Therefore, they can be factored out. And when we do, we will have 2x minus 3 times what's left, which is 7a. And then since there's no coefficient, that implies a 1. That'll be plus 1. Now, does this make sense? Well, of course, 2x minus 3 times 7a recovers that, and then 2x minus 3 times 1 recovers that. So it works out just fine. Okay, what about this one? Well, here we have the common term of x minus 3 here and x minus 3 here. So we can write down x minus 3. And what do we have left over? We have a 6y cubed. And then we have a 7. And this, again, recovers nicely. X minus 3 times 6y cubed gives me this expression. And then x minus 3 times 7 gives me this expression. So it works out just fine. Okay, so that's pretty much all we want to talk about relative to factoring out a kind of binomial factor. We're going to use that as a tool to learn about factoring by grouping. Now, take a look at this expression. This expression has 4 terms. Okay, and how do we factor with 4 terms? Well, we do that by, yeah, you guessed it, we're going to do some grouping. We are going to group these two. We're going to group these into two sets of 2 terms. Hopefully, they have a common monomial, and then we're going to factor that monomial out using the distributive property in reverse. And then hopefully, there will be a common binomial that we can factor out as well. So, we actually have a procedure for factoring by grouping, and here it is. First, group the terms that have a common monomial factor, and notice that this term and the xy and the 5x have a common x. So we're going to group them together, and that's why we have the grouping symbols. And then this term and this term actually have a common 3 because the factors of 15 are 3 and 5. All right, cool. Now what are we going to do? Well, since they have common factors, we can use the distributive property in reverse and factor them out. And that's exactly what we did here. So here we have x times the quantity y plus 5, and if I use the distributive property in the forward direction, I will recover this, xy plus 5x. Here I have 3 times the quantity y plus 5, and I can use the distributive property to recover the 3y and the 15. Okay, awesome. Now, if each of the term has a common binomial factor, and it turns out this is a binomial factor and this is a binomial factor, and they are the same, then we can use the distributive property again, just like we did in the first part of this video, to produce this. And this right here is the factored form of that. Don't believe me? Well, go ahead and use FOIL and see what you get. You'll get xy you will get 5x, you will get 3y, and you will get 15, which is the original equation. Now, however, if the terms do not have a common binomial factor, then the expression is not factorable. Now, consider this expression. Okay, and let's go ahead and use our procedure. So we are going to identify terms that have a common monomial factor. So once again, this has an x, this has an x, so here they are. The 3y has a y, and the 24 has a 3 in it. Okay, now we can use the distributive property in reverse. And there we go. We factored out the x, and we factored out the 3. And yet, you can use the distributive property in the forward direction to realize that they are the same, that they are equivalent. Okay, now, if each term has a common binomial factor, then we can use the distributive property again. However, these terms do not have a common binomial factor. As a consequence, since they do not have a common binomial factor, they are not factorable. So this expression is not factorable. And that pretty much is our approach for factoring by grouping. Let's take a look at a couple of examples, 5 to be precise. Okay, here's our first example. Okay, so if possible, factor each polynomial by grouping. And here we have this one. Now, there's actually two ways to approach this. Notice that this term and this term have a common x. And then this term and this term have a common 5. So I can go x squared minus xy, that's my one group, plus 5x minus 5y. Okay, now I have a common monomial factor here. It happens to be an x. I can factor that out. And here I have a common monomial factor. It happens to be a 5. I can factor that out. I have a common binomial factor here, a common binomial factor here. I can use the distributive property again, and that will give me x minus y times x plus 5. And there we go. Now, there is another way to do this. Notice that the x squared and the 5x have common factors, are common factors. So I can write x squared plus 5x plus. And also notice that negative xy and minus 5y have a common factor. It happens to be y. Okay, I can use the distributive property in reverse, and now we'll have x times x plus 5. And over here, I have a y, so plus y times minus x minus 5. So these two are not the same. However, notice that they are the opposite of each other. So what and also notice that this could also be written as minus 1 times 5 plus minus 1 times x plus minus 1 times 5. Okay, and then we could factor out the minus 1. The point matter here is I can factor out a minus 1, which would give me a minus y here, and that'd be multiplied by x plus y. Minus y times x is minus xy, minus y times, that should be a 5, not a y. Minus y times 5 gives me my minus 5. And now I can bring this down. So now I have a common binomial factor, which I can factor out, and that will be an x plus 5, and I will multiply that by an x, and then by a minus y. And notice we get the exact same result. So typically, if an expression like this is factorable, there tends to be two ways to approach it. Okay, let's look at example B. Here we have x squared plus ax plus 3x plus 3y. Okay, now I could combine x squared with 3x, okay, because they have a common monomial, but if I did, I would be left with a 3y and an ax, which cannot be combined. Okay, so it might be better if we combine x squared with ax, and then 3x with 3 and 3x with 3y, because then these will have a common factor and this will have a common factor. And that will give me x squared plus ax plus 3x plus 3y. Okay, now here we have a common monomial factor. It would be an x. I can factor that x out. Here I have a common monomial factor. It happens to be a 3. And that will give me, and I can factor that out, giving me 3 times quantity x plus y. All right, now check this out. This and this are different. Therefore, we have different monomial factors. We cannot use the distributive property again. So this is not factorable. For part C, we have this has an x and a y. Okay, we could try to group it with a 5x, but then these two terms don't group. So however, we can group the x, y with the y, and then we can group the 5x with the 5. They will both have common factors. And that will give me xy plus y as one group, and then 5x plus 5 as the other group. Okay, so this one has a common y. We can factor that out. That'll give me y times the quantity x plus 1. And over here we have a 5 that we can factor out. That'll give me a 5 times the quantity x plus 1. Okay, now we have our common binomial. And here we will have x plus 1 times y plus 5. And as usual, there is another way to do this. Suppose that instead of grouping the xy with the y, I group the xy with the 5x. In that case, we will have xy plus 5x, and then I'm going to have a y plus 5. Now you're going to say here, but wait, there's no common monomial factor there. And the answer is, well, no, it appears that there isn't, but actually there's an implied 1 there, but let's just go ahead and run with this. Here we can factor out an x, and that if we do, we will have x times the quantity y plus 5 plus over here the quantity y plus 5. Okay? As it turns out, we have a common binomial factor here and a common binomial factor here. And then we will, so we can have y plus 5 times x, and then since there's no coefficient over here, that implies a coefficient of 1. So we can do x plus 1. And will that work? Well, we can go ahead and FOIL to find out. Well, actually, it does work because we get the exact same thing we have over here. So once again, if they're factorable, there's usually 2 ways to do it. Okay, now here is part D. That's the one that usually comes after C, correct? Okay, so here we have a 9AC, and then over here we have a 72AD. They both have common factors, so at least an A. Okay, so I can write that as 9AC minus 72AD. Okay, and that's going to leave me with a negative 8BC, BD, I apologize, plus BC. Okay, well, we can rewrite this as 9AC minus 9 times 8AD plus, and notice here we have a common factor of B plus B times negative 8D plus C. Now over here I have a common factor of 9 and A. I can factor those out. That'll be 9A times the quantity, and a 9 and an A here, C minus 8D plus B times the quantity, negative 8D minus C. Of course, there's no reason why we, plus C. There's no reason why we can't change the order of these. That'll be 9A times the quantity C minus 8D plus B over C minus 8D. And then this will give us, factoring out the binomial term, C minus 8D times 9A plus B. Okay, as I mentioned before, if they're factorable, there's usually two different ways of doing it. So here's the other way. Okay, we're going to combine the 9AC with the BC, and that will give me 9AC plus BC plus negative 8BD minus 72, or 8 times 9AD. Okay, so here I can factor out a C. Okay, and if I do, I'll have C times the quantity 9A plus B. Okay, here I can factor out an 8D plus 8D times the quantity negative B minus 9A. All right, well, once again, notice that this term, that these two terms are opposites. So I can multiply this entire thing by negative 1, and if I do, I will have C times the quantity 9A plus B is equal, no, plus, no, minus, because remember I'm taking the opposite, minus 8D times the quantity B plus 9A. And of course that can be that can be rearranged, so we would have C 9A plus B minus 8D 9A plus B, and then we will have 9A plus B times the quantity times C minus 8D. And there you go. Then for my last example, we have this. Now notice that we have a common term of a y here and a y there. And then here we have a common term of an 8 and an 8. So this can be grouped as 5ya minus 7y squared plus negative 8 minus 8y. Okay, so I can factor out here a y. That will give me y times the quantity 5a minus 7y. Over here I can factor out an 8. That'll give me 8 times negative 1 minus y. If I wanted to, I can basically factor out a negative 1. That would give me y is equal to 5a minus 7y minus 8 times 1 plus y. Basically, there's no way that these two binomials will ever be equal. There's nothing you can manipulate. Therefore, they cannot be factored out, and therefore this is not factorable. And that is all I have for this part of the video. Just stay tuned for me to get Hawks up, and then we'll do a couple of examples. Okay, so here we are back in Hawks, and it is time to start doing some practicing. 5a minus 8 minus 7y minus 8a, and we need to, or 8y, and we need to combine these, and we need to see if we can factor these. Well, notice that we can combine them. We can group them as follows. We can group the 5a and the negative 7y. I'm sorry, the 5ya and the negative 7y. And then we can group the negative 8 and the negative 8y. Okay, so the common term here is a y. That will give me y times 5a minus 7y. And here we can factor out an 8. now will give me negative 1 minus y. Now I can take the opposites here. Now it'll give me y is 5a minus 7y, just writing that down. So this I can basically take the opposite of 8, which is negative 8, and then take the opposite of negative 1 minus y, which is 1 plus y. Now notice, this binomial factor and this binomial factor are different. Therefore, we cannot use the distributive property in reverse a second time, and this is not factorable. Okay, so what we would do over here in Hawks is we would come over here, click the not factorable by grouping, and submit our answer, and we better be correct, and we are. Okay, moving on. Okay, here we want to factor the entire expression by grouping. And notice that the first two terms have an a in common. Okay, so we can group the first two terms. That would be AR plus AU. And then the second two terms have a z in common. So plus RZ plus UZ. Okay, cool. Now here we can factor out the a. That would give me a times R plus U. And here we can factor out the z, or use the distributive property in reverse to take out the z. Z is equal to R plus, or z times R plus U. Now notice the binomial terms are the same, so we can use the distributive property on the binomial terms like we did in the first part of this talk. And that will give us R times R plus U times A plus C. And hopefully that will work. Now, parentheses, and they'll give you both. Just type in R plus U. And then you can just tab over. Or maybe you can close parentheses. No, it doesn't like when you do this. Just basically space on over. Parentheses again, and it'll give you both. And then type in A plus Z. And then you can submit your answer. And boom. And now we can move on. And let's look at this one right here. Here we have 4CP minus 4UY plus PU minus 16CY. Okay, so once again, we want to group these according to common factors. Now, I could group these two together. I could group the 4CP and the 4UY together because they have a common 4. But then I would have these two factors and they have nothing in common. So it might be better if I group the 4CP and the 16CY. Okay, and then I'll be left with the negative 4PUY and the PU. I just love that expression. PU. Okay, so over here I have a 4 and a C in common because this can be written as 4 times 4. So I can factor out a 4. I can use the distributive property in reverse and have 4C. Now then I'll have P minus 4Y. Over here I have a U in common, so I can take that out. And then I will have a negative 4Y plus P. However, notice that I can just write that in reverse. Let me just go ahead and do that. I will have 4C P minus 4Y plus U P minus 4Y. And so I have a common binomial factor. I can use the distributive property again. That will give me P minus 4Y times 4C times U. And there you go. Okay, so this problem involves factoring out a common binomial, which we've seen before. So notice that we can write this as, we can factor out the y plus 2. And then we will be left with the 7y squared. And then the 6y. Or just the 6. And so that would be our answer. Okay, so here we have ay minus 4by plus ax minus 16bx. So we could group together ay and 4by, so let's go ahead and do that. We will have ay minus 4by plus 4ax minus 16bx. And since 16 is equal to 4 times 4, I'm going to write that as 4 times 4. That way we can see we actually have a common factor of 4 in there, x. Okay, so here we have a y that's common, so we can use the distributive property and reverse it and take that out, and that'll give us y is equal to a minus 4b. And here we have a 4x in common. So we can use the distributive property in reverse and factor out a 4x. And then notice that the binomial terms are common, so we can go ahead and factor that out, and that will be a minus 4b times y, and then times 4x. And there you go. Okay, for this problem, notice that the 6ac and the 9bd actually do have a common factor because they both have a common factor of 3. And then, but bc and 54ad don't appear to have a common factor. So we probably can't do that, but we could do 6ac minus 54ad. So let's try that. And then that'll be plus negative 9bd plus bc. Okay, so the first term actually has a 6 and an a in common, because we can rewrite this as 6ac minus 9 times 6 times ad. Okay. And then over here, we can factor out a 6 and an a. So we have 6a, and then we have left what we have left. We have a c minus 9d. Plus, and over here, we can factor out a b. And then we're left with a negative 9d plus c. However, we can just flip that order. And if you do, we will have 6a times c minus 9d plus b times c minus 9d. And then we can, and now we have our common binomial term at c minus 9d. And we are going to multiply that by 6a. And we're going to multiply that by b. And there you have it. And that is all I have for this particular lesson. If you have any questions, please feel free to reach out to me. And this is Bob Boyle, signing off.